We are now ready to close the first week of our lecture. In this week, we have talked about introductory material on numerical methods. So we have learned certain fundamental aspects of numerical methods. What do numerical methods do and how do they do it? We have learned that numerical methods always involve certain errors. They are never exact. We can bring down the errors to acceptable level. This is an inherent feature of numerical methods. Further, we have seen that numerical methods are not there existing in a vacuum. They are coming from the intention of solving physical problems. Physical problems are usually modeled in terms of mathematical equations. This procedure is absolutely important because modeling leads to abstraction of problem, and then one model can be applied to many different types of problems. For instance, the modeling in fluid mechanics involving mass and momentum equation is applicable for the stirring of tea in a teacup to the tsunami in a sea. The model equations requires simulation, that means solution, and these simulations most of the time will require application of numerical methods. It may be possible in some special cases to have analytical solution, but as soon as we try to include certain complexities which are inherent in physical phenomena, the analytical solution will not be able to take care of those complexities. We have to get into the numerical methods. In particular, we have talked about the root finding this week, and by root finding we actually mean finding the solution of one equation for one unknown. We have seen two different methods for root finding. One is bisection method, another is Newton-Raphson method. Both are very important. They have certain similarities and certain differences. Bisection starts from an interval within which the intended root resides, and then it iteratively closes the gap, closes the interval. Newton-Raphson method has a different philosophy. It starts from an initial guess. It is better to have an initial guess close to the root, but there is no place of interval here. So it starts from an initial guess, then it linearizes the function for which we are trying to find out the root, and from that linearized function it calculates the root. Iteratively then it updates the root. So both methods are iterative, and as we have already seen from example that Newton-Raphson methods take less number of iterations for convergence. For your assignment, you will have some simple questions from modeling and analytical solutions, as well as some simple calculations for root finding. Even though all of them are simple, it is important to go through all of them. The analytical solution that is there in assignment that are not discussed in lecture. However, these analytical solutions are in some sense some of the prerequisites of this course. Mathematics is a prerequisite of this course. So simple analytical solution, I believe that you already know them. So that is there in assignment. So this is your previous knowledge. You already know this analytical solution, I am hoping. If you do not know this analytical solution, then my suggestion will be you go back to a mathematics textbook and look at those analytical solutions from there. The solution of the homeworks I'll distribute later, where you can match your solution. In summary, what we have seen here is that numerical methods uses repetitive arithmetic calculation. These are very important terms here. Both repetitive and arithmetic is important. We deal here in numerical method only with numbers and not with symbols. Most of the time with real numbers, sometimes with integers, rational or complex numbers, but most of the time with real numbers. And these are simple calculations, but they are repetitive. So same type of calculation we have to do again and again and again. That way, it can be done by someone who is not an expert in mathematics, and also it can be programmed very easily in a digital computer. Numerical method will always give approximate answer, it is never exact. And solution of practical problem requires modeling, and most of the modeling equations that are coming from modeling, that will require numerical solution. In root finding, where we are solving one equation for one unknown, and these two approaches, that is starting with an interval and closing the interval, that is the bisection, and then linearizing the problem and solving the linear equation iteratively, that is Newton-Raphson, or in some literature it is called Newton's method. Now, modeling is very important if you are an engineer or scientist. For many problems you see around you, you can start practice creating models for them. This is an important skill to acquire, and this will help you in understanding these subjects as well as many other subjects. In the examples that we have shown in lecture, the root finding we have conducted for simple algebraic equations. Taking a cue from there, you try similar procedure using manual calculations for some equation that involves trigonometric or logarithmic functions. It will give you much more confidence on the process. In coming week, we'll talk more about programming. We'll talk about writing pseudocode. You have already seen some example of pseudocode. You may or may not have understood them, and I did not discuss them in great detail, but now I'll discuss in little more detail in coming week. Also, you will learn a little bit of Python programming and some of the useful packages in Python which could be helpful in numerical computing. Python programming is necessary if you are interested in this, but you may use for programming any other language. But when I'll discuss Python programming, I'll discuss the general features of it, which in some form or other applicable to all programming languages. The kind of exercise that I'll ask also next week, even if you are not using Python, you can still do those exercises in your own language. So you may or may not use Python programming, but going through the lectures next week will be useful for you. My suggestion to you that this week's assignments, they are very simple problems and you finish them as quickly as possible so that you can get ready for next week material. Thank you. That's all for this lecture, and that's all for this week.